Today we're talking about probability of composite experiments, which involves dependent and independent events. So let's talk about independent events first. A composite event consists of two or more simple events, such as rolling a number cube and spinning a spinner. Independent events are events where the outcome of one event does not affect the outcome of the other event. So rolling two number cubes, rolling one number cube does not affect rolling the other number cube. So that would be an independent event. They are independent of one another. The probability of two independent events can be found by multiplying the probability of the first event by the probability of the second event. So we're going to use multiplication to find probability of independent events. So let's look at the first example. We have two spinners here, and they are going to be spun, and we want to know what the probability that both spinners will show an even number. So these are independent events because spinning this spinner does not affect spinning that spinner. So we want to know the probability that both of them would show an even number. So if we look at this one has 7 spaces, and we want to start with the probability of the first event. So what is the probability the first spinner is even? So we have 1, 2, 3 evens out of 7. So that's our first probability. Then we look at the second one. The second spinner is even. So we have 8 total, and we have 1, 2, 3, 4 evens out of 8. So we're just doing the probability of each simple event. And we can reduce these. Now, to find the composite experiment, to find the probability that both would be even, we're going to multiply. So I'm taking the first probability times the second probability and multiplying. So 3 times 1 is 3, 7 times 2 is 14. So just to reiterate what we just did, we take the probability of the first event, that the first spinner would be even. We got 3 out of 7. We took the probability of the second event, which was the spinner would be even, which was 1/2, and we multiplied. Okay, let's look at another example. A spinner and a number cube are used in a game. The spinner has an equal chance of landing on one of 5 colors: red, yellow, blue, green, and purple. The faces of the cube are labeled 1 through 6. What is the probability of spinning a blue and then rolling a 3 or a 4? So we're going to find the probability of spinning a blue first. So I have a spinner with 5 colors, so my total is 5. And I want to know the probability of blue. And there's only one blue section, so the probability of blue is 1/5. Then I want to do the probability of 3 or 4. So I have a number cube, 1 through 6. I have 1, 3, and 1, 4, so that's a total of 2 options that I could do out of 6, which would be 1/3. So I've done the probabilities of the events separately, and now I want to combine these. So the probability of spinning a blue and rolling a 3 or 4 is 1/5 times 1/3. So I have a 1 in 15 chance of getting a blue and 3 or 4. So again, the probability of blue was 1 out of 5. The probability of a 3 or 4 was 1/3. And so 1/5 times 1/3 is 1/15. Okay, let's look at another example. A number cube is rolled and the spinner is spun. Find the probability. So this spinner has A, B, C, and then the number cube is 1 through 6. So I want to know the probability of 4 and a consonant. And remember, consonants are not vowels, so our consonants would be B and C. So the probability of 4, let's do that first. I only have 1 4 on a number cube. So I have a 1 in 6 chance of rolling a 4. The probability of a consonant, and I'm just going to put C-O-N-S, the probability of spinning a consonant is 1, 2 out of 3, 2/3. So the probability of 4 in a consonant, remember I'm going to multiply 1/6 times 2/3. And remember, when you're multiplying fractions, you can cross-reduce. And I get 1/9. I have a 1 in 9 chance of spinning or rolling a 4 and spinning a consonant. Okay, the probability of spinning an odd or rolling an odd and spinning a B. So if I think of a number cube, I have 1, 3, and 5 as odd numbers. So that's 3 out of 6. And a B, there's only 1 B on my spinner out of 3. So that's 1/3. 3/6 can be reduced to a half. And now I need to multiply. 1/2 times 1/3. 1 times 1 is 1. 2 times 3 is 6, is 1 out of 6. So what these probabilities really mean is if I do the experiment 6 times, 1 out of every 6 times I would get an odd and a B. Okay, I would like for you to try example 4 on your own. It's a little bit different problem. We're talking about choosing different snacks and drinks, but you're going to do the probability the same. We'll check that in class later. So now let's talk about dependent events. If the outcome of one event affects the outcome of another event, the compound events are called dependent. So what happens on the first event is going to affect what happens on the second event. So let's look at this example. There are 2 white, 8 red, 5 blue marbles in a bag. Once a marble is selected, it is not replaced. That's the key there. It is not replaced. Find the probability that 2 red marbles are chosen. So just like what we've done previously, we're going to do the same thing. We're going to find the probability of each event and then multiply, but it's going to be a little different how we find the second event. So the probability that the first marble is red. I have 8 red marbles. Out of, that's 2 plus 8 is 10, plus 5 is 15. So I have a total of 15 marbles, and 8 of those are red. 8 out of 15. Now, the probability that the second marble is red. Here's where you really have to think here. If I drew a marble the first time, a red marble, that means I would only have 7 red marbles left. So we have to use subtraction. We have to say, well, I had 8 to start with. If I drew a red the first time, then I would have 7 red left. And since I drew 1 and did not replace it, I have 7 out of 14, which is 1/2. So let's look at this again. I had 8 red out of a total of 15. I drew 1 and did not replace it. So now I have 7 red out of a total of 14, which is 1/2. So now I'm going to take these probabilities, 8/15 times 1/2. I can reduce, make this an easier problem. So 4 times 1 is 4, and 15 times 1 is 15, 4/15. Now we're going to use the same scenario here, that there are 2 white, 8 red, and 5 blue marbles in a bag to do these problems here. So what is the probability that we would have 2 blue marbles? So we had 5 blue, and so that was 5 out of 15. This is the probability that the first one would be blue. If I draw a blue one and don't replace it, the probability that the second one would be blue would be 4 out of 14. I took 1 away from the blue and 1 away from the 15. So this reduces to a third, and this reduces to 2/7. So I'm going to multiply a third times 2/7. And I get 2 out of 21. I have a 2 in 21 chance of getting 2 blue marbles. Okay, let's look at B. Now, each of these problems is separate from one another, so we're going to start fresh on every single one. So what I mean by that is we still have 15 marbles here. So we want to know the probability of 1 white marble and then a blue marble. So I have 2 white, so the probability of drawing a white is 2 out of 15. Then the probability of a blue, I have 5 blue, but I took 1 away when I drew the white marble, so the blue is 5 out of 14. So now I'm going to multiply the probability of white and then blue is 2/15 times 5/14. Please make sure that you're reducing. It makes these much easier to multiply. This would be 1, this would be 7, this would be 1, this would be 3, and I have a 1 in 21 chance of getting a white and then a blue. I'd like for you to pause and try C on your own and then check your work. Hopefully you've had a chance to try this. So you should have gotten the probability of red was 8 out of 15. The probability of white was 2 out of 14, which reduces to 1/7. So 8/15 times 1/7 is 8 out of 105. All right, so I'd like for you to try D on your own, and we'll check that in class later. Okay, a jar contains 3 yellow, 5 red, and 4 blue candies. After a candy is selected, it is not replaced. Find each probability. So I have a total of 20 total candies, and I want to know the probability of 2 red. So I'm going to do the probability of the first being red is 5 out of 20, which reduces to a fourth. And then the probability of the second one being red, if I drew the first one and it was red, then I would only have 4 red ones left, and I would have out of 19. And now I'm going to multiply. 1/4 times 4/19. I can reduce 1 in 19 chance. I'd like for you to try these last 2 on your own, and then we will check those in class later.